Now, first of all, I would like to say that I think we had a series of 6 very good presenters and presentations, and I'd like to ask you at this point to acknowledge the quality and the good presentations by everybody. And we're starting now the panel discussion. I'd like to remind you first that we had altogether 6 talks, and we have only probably 25 minutes for the discussion. So I invite you to come forward and ask questions or give comments to any of the speakers. I'd like to remind you to identify yourself when you come, and also to say who of the speakers you are addressing. Yes, please.
Hello, my name is Teun van Dille from the Netherlands, from the National Institute for Public Health in the Environment. My question is for Mr. Harrison. Thank you for a very nice presentation on the use of the effective dose. My question is not about the effective dose, but about the equivalent dose. You said that the new proposal is to discontinue the use of the equivalent dose as a protection quantity for deterministic effect. And as I understand it now, the radiation weighting factor which is in there is let's say, a relative measure of the damage that the incident particles leave behind. And if you step away from the equivalent dose, how are you going to deal with the damage? Because the absorbed dose is not yet a measure for the damage that is created by the radiation. So how are you going to deal with that then?
Thank you. Well, the radiation weighting factors that are used apply to stochastic effects. I mean, in most cases for which we're setting those deterministic dose limits, the concern will be penetrating low LET radiations in any case. But if we were looking at high LET radiations, then the radiation weighting would be lower for deterministic effects than for stochastic effects. And we think that the limits are set such that the quantitative levels of those limits wouldn't need to be changed if you were considering absorbed dose in grey. So that's the situation. I mean, we need to look in a little bit more detail at particular issues such as irradiation of the lens of the eye, but that's what we think. Remember, this is just a proposal, and it's not endorsed in any way by ICRP.
Thank you very much.
May I just add, I don't think the proposal is to abandon the double sub-R. It's just the proposal is not to have a extra name for something which is in the part of the definition of effective dose. One doesn't need to have an extra name equivalent dose for that, because none of the limits refer to the equivalent dose of those organs which are specified for stochastic effects. I think that's what's behind it. François?
My name is François Bochu from Switzerland. I really appreciated the proposition of the task group and also the modification of proposed by ICRU. And I have a question for Akira Endo. What will be the effect of your proposals if they are accepted on the manufacturers and the instrument? Will we all have to change the way our instruments are answering in low energy X-rays, for instance?
Thank you very much. This is a very important point. And ICRU report committee 26 considered the following three points to create new system. The first is to simplify the system, because we now use two different dose system. One is defined by the ICR sphere and quality factor, and other is the Kalman phantom and radiation weighting factor. And to simplify, the system is very important. And the second point is to apply to high all energy and all particles. And the third point, this is very important to minimize the impact of changes on the current radiation protection system. So this new proposal is revised the conversion coefficient, but does not change reference field and calibration phantom and calibration procedure. So problem is just revise conversion coefficient. It will affect just conversion calibration factor of the instrument. So ICRU believes this new proposition, the effect of new proposition is not so significant.
Well, I think the committee was right from the beginning aware that they wouldn't introduce changes just to for academic reasons, but for good practical reasons, and that there should be no big impact on the current use of dosimeters and the way they are calibrated. So I don't think there will be major differences.
My name is Avi Ben Shlomo from Israel. The ICRP had good dosimetry system to measure internal radiation dose and external radiation dose. But unfortunately, in the last 15 years or more, there is a large group of thousands of people that the ICRP don't give dosimetry answer for this group. This group is nuclear medicine workers that work with short-life radionuclides. Those people don't give any chance to measure their internal dose. If they don't give any chance to be measurable in whole body contour, or their urine sample will never go to the lab that measure the internal dosimetry that they get, because it's decay. I speak about radionuclides with half-life of several hours and less, until it can reach to 20 or 10 minutes radionuclides that produce in nuclear medicine. Now, there is several works that combine the external dosimetry with internal dosimetry and takes the external radiation dose of workers that get short-life radionuclides and try to assess in the workplace what is the absorption of their radionuclides into their body. I suggest that the committee will consider to establish such a set of factors that could be combined and combine the internal dosimetry by simple measures in the workplace that could measure external dose. Thank you.
Hans, I can.
Anybody? Yeah.
I think that's an excellent suggestion. The Centers for Disease Control in the U.S. is the agency that would respond to, say, a dirty bomb accident. And we had done some work along with Nolan Hertel at Georgia Tech in Atlanta to use our computational phantoms as simulated contaminated individuals. We used ICRP biokinetic models. You would have to know what the radionuclide was in the time since intake, and then we modeled the external gamma field and modeled ion chambers in GM counters. So essentially you had a measurement of external count rate and would essentially a conversion coefficient to effective dose. So this was used for radiological triage following a dirty bomb. That process could easily be done for very short half-life radiopharmaceuticals used in nuclear medicine. So I think in committee too, we'll seriously look at that. I think that was somewhat looked at by the environmental. That's also an opportunity to fold that into task group 90, and so we'll be having that discussion in committee too. Thank you.
Thank you, Wes, for this answer. Christian?
My name is Christian Straffer from Germany. You can imagine, I certainly, John, have very large question marks with respect to the effective dose. If I listen correctly and understand it correctly, the effective dose gets now more risk, not only related, but calculated risk. And this was never the intention of effective dose. In ICRP 103, we have very clearly stated, more or less, it's forbidden to calculate risk in a certain situation on basis of the effective dose. And I think this is quite clear. We have said, if you want to calculate risk, we have to orient the sex, the age, and other factors. And therefore, effective dose was meant for compliance of dose limit. Let's go a bit back in history. Before effective dose, we had whole body dose as a dose limit and nothing else. And the reason for going into effective dose was that, especially after internal irradiation exposure with a radionuclide, you have very heterogeneous distribution of dose. One example, of course, is iodine, but also with the exposure from natural sources. And I think this was the main point at that time. Radon had no significance for the whole body dose. Therefore, effective dose was taken. But we always have said not to calculate risk. It's risk-oriented. It's a compliance for the dose limit. And of course, we are aware that the scientific basis has some question marks. And the question mark becomes tremendous if you use effective dose for the fetus. If you look at the fetus, the stochastic effects which you have after exposure of the fetus or the cancers which you see in children, it's leukemia and central nervous system cancers. And this is never mirrored by effective dose, especially as if you see that there is no bone marrow active during a very large part of the prenatal development. It's the liver. So I can't understand to use effective dose for the fetus. Everybody who knows a bit about developmental processes will only shake the head. So certainly effective dose is very important, very useful, but it's not for calculation of risk. This is completely different point, and it is risk-oriented, risk-related, and if we use the fixed weighting factors, you cannot calculate risk on that basis.
Okay, well, I think there were a couple of particular points there, and I'll answer them briefly, but probably not to your satisfaction. What we're suggesting is in no way suggested as a replacement for doing a risk analysis, where you would use organ dose, which is a scientific quantity, and you would use your best estimates of age and sex-related risk based on the epidemiology for the most appropriate population group. That's clear. You would look at uncertainties as well. However, the point is that effective dose is recorded in these medical procedures, and the question is asked, it is related to risk, can it be used as a rough indicator of risk? And the sorts of calculations that you do suggest that it can, with quite substantial caveats, and you were linking it through there to the fetus, I think, and that would certainly be one of the issues. You would definitely not use it in those sorts of circumstances. You wouldn't use it, for example, if you were considering mammography, where you would look at the dose to the breast tissue. But under particular defined circumstances, and depending on the dose, it can be used, and people do. I mean, we all do it, don't we? You can use it as a rough estimate of risk. To put what you have to be careful then is that you don't believe too much in the number that you have calculated, because of the increasing uncertainties as you go to lower doses. So that's the first point. The second point was about effective dose to the fetus. And it has to be said, Christian, that I think you were chairman of Committee 2 when we put through some of the work on effective dose, including effective dose to the fetus.
And said there are no weighting factors for the fetus. And I think I still agree with that.
And it is true to say that you've written an article on that very topic where you say, actually, this is the best we can do because we've got no weighting factors for the fetus.
Well, I may add just one thing. I think the whole thing has been, the work of this group has been triggered off by the community of working in radiological diagnostics. And without any pushing from ICP, in fact, just the opposite, trying to stop them or slow them down of using it. It is used in particular in North America in the context of radiological diagnostic for risk assessment. And we have had long discussion, for example, with Brenner, and say that's totally incorrect. You cannot do that. On the other hand, what we then said, the ICP cannot always just say, don't do that, don't do that, don't do that. We have to give them some guidance what should be done if risk assessment is there. But we have to very clearly distinguish between radiation protection, which is effective dose, and risk assessment is something else. It's just a question, can in the context of risk assessment the effective dose play some role? And there we probably have to still discuss it quite a bit. Yeah.
Yes, thank you very much.
Sorry.
Thank you for all the speakers. It was a very interesting evening and we learned a lot. I have a comment to Dr. Harrison and maybe to others. You see, we are measuring individual doses externally and internally. And we already have a lot of uncertainties in the measurements. We all know that, what we have. Then we have quality factor, we have RBE, we have radiation weighting factors, which all have their own uncertainties, again, as we know. Based on that, we come and we calculate equivalent dose. And then we calculate effective dose. And based on all those we added, we come to a value of individual dose. This individual dose, I still do not know what would be the uncertainties on that and the confidence level, that we get at the end. And based on this, we will do epidemiological studies of a large group. That is what is being done. Just a moment. That is what is being done in different countries. And then with all these risks, with all these values, we come to a risk from epidemiological studies. I quite agree with you, and also I sympathize with the comment with Dr. Schaeffer, but I like to say that you are doing something in the right direction. We have to think overall in the radiation protection system and the quantities that we are using, because as we understand, there are so many uncertainties in these areas, and we have to be very careful. So what I'm recommending, or what I'm suggesting is, or what my question is, how valid we can rely on these quantities that we are using at the end, and how we can answer to the questions of students that they have so many questions in their minds when we talk in the class on so many percentages. Thank you.
Who wants to answer to that?
Well, I'll say something, then perhaps others would wish to add. But one particular point is that effective dose, of course, doesn't belong to the individual. It's calculated for reference phantom. So it really is the dose that would be received by a sex-averaged reference phantom under the circumstances of exposure of perhaps an individual in occupational exposure or whatever. Now, of course, there are uncertainties associated with that, and in some cases you might wish to have some idea of what the uncertainties might be. But the way the system of protection operates, as Francois said, we publish dose coefficients as single point values for use in protection. And in all cases, we're talking about setting of constraints or reference levels and optimizing below. So that process continues irrespective of uncertainties around those values. And another point you made was about epidemiology. It should never be the case that these protection quantities are used in epidemiological studies where you need a scientific quantity organ dose in grey.
Also, do you want to add anything?
Just few other words about the range of uncertainty concerning internal dosimetry. I mean, that really depends on the situation. When you have a person who is contaminated, when you know the radionuclides, when you know the time of intake, when you know the pattern of intake, when you know the chemical form of the radionuclides, when you know everything, and when you are dealing with the radionuclide for which we have many human data, the uncertainty would be very low. But by contrast, if you deal with retrospective dose assessment, and if you need to calculate the dose to some people who was contaminated with an unknown form of radionuclide, when you do not have when he was contaminated. I mean, he can come to you weeks after contamination, or you can just discover by a medical measurement that he was contaminated. You have no idea of when he was contaminated. In such a case, you can have a very high uncertainties. But again, when you calculate the effective dose, it is by definition not uncertain, because we are dealing with reference person, reference model, reference parameter value. So this is can be difficult to understand, but this is something you should understand. And by the end, I have been asked during the break about the range. So we may have a factor 2 in some case. When you have absolutely no idea of what you are dealing with, and you may have a factor 2. It can be the case.
Thank you, Francois. I think that's Chris in the dark.
Yes, I'm in the dark. Thank you, Hans. Given the time of day, I'll keep my question short and pointed maybe, and Jean will be happy it's not directed to him. So for Dr. Endo, thank you very much for the discussion on the ICRU proposal to use Emacs as a basis for operational quantities, which seems very sensible. My question is that as presented, it's based on the reference adult male and female phantoms results. Has there been any discussion in ICRU whether it would be either appropriate or useful to look at results coming from the pediatric phantoms at some point as well? Or have there been any preliminary calculations to say whether or not it would make much difference if you did anyway?
Okay, at present, ICRU defined the operational quantity based on the maximum barrier of effective dose for the adult. And the reason is on dose is increased with decreasing the age. So in the radiation field, on dose become higher. But children, the on dose of children become higher compared with the adult. But other things is we have to consider the irradiation geometry. It affects, as I explained, irradiation geometry affects effective dose. And in case of a public exposure, the situation is the irradiation geometry is maybe rotational and isotropic. And in this case, effective dose small compared with AP geometry. And the Emacs function is defined for the maximum barrier for the adult AP geometry in the low energy region. And this function covers for the effective dose for the children. It gives a conservative or a reasonable estimate for the children. So I think the Emacs for the adult is sufficient for the protection of the children, I think.
Donald Kuhl from the United States. My question is also for Akira Endo. If I'm remembering the figure that you put up for Emacs correctly, at low energies, the value was a fair bit lower than the current H10. In other forums, including an NCRP Council Committee and work being done for the Environmental Protection Agency, there's an examination of whether in that same energy region, the RBE or the radiation weighting factor should be something greater than 1.72, other numbers have been proposed. And my question for you, and I suspect it is for you to speculate rather than you would know for sure, is whether that means that in the end, it would be exactly the same because they would cancel each other out because your operational quantity would be lower and the effect would be higher, or whether it would be a doubling.
I'm sorry, I cannot answer your question at present. So I have exact information that you say. So I will try to discuss with you later.
Don, this was the work that Keith Eckerman was doing for. Yes. Yeah. So there was a proposal to have essentially an energy-dependent WR for photons. Okay.
I believe that is the last question we can take because I was asked to close promptly at 5 o'clock, which was 30 seconds ago.
Thanks for the speaker. I'm Xiano from Han University. I have a short question to Dr. Paquet. Then, if we consider the uncertainty and variability for or a parameter in internal dosimetry, we can get some internal dose distribution, not a single value. So here's my question. How can you use this internal dose assessment? So for example, in ICRP publication 101, the representative value can be recommended using 95th percentile value. So how's your opinion? So how can we use internal dose distribution considering some uncertainty and variability of our parameter?
When you are talking about internal dose distribution, are you talking about distribution of the
Not a single
radionuclide
value.
in the body?
No, just if we consider uncertainty and variability of our parameters such as transfer rate or absorption rate and so on, so we can get internal dose distribution, not a single value.
Francois, I believe that the question is you go through all the parameters of the biokinetic models, and right now you're using central estimates for each one, right, a reference value. You could look at the literature and ascribe a
right.
probability distribution for each parameter, and then you would use
How
random
can you
sampling.
use that distribution?
It's not done by ICRP, but it's a process that could be
Yeah.
done to get a realization of a distribution of doses, right? But,
Yes, the parameter value are chosen as to be the central value. I mean, of the distribution. I'm not sure if I really understand an answer to your question, but when you have a set of different value with a great variability, the idea. But it's a problem of statistics. You choose just choose the central value to determine the central parameter.
I think in accidental situation, which means it can be very high dose, then I think if we use just only central value or mean value, then it can be a little bit dangerous. So I think in this situation, we can use other percentile value other than central value.
What we usually recommend is to use this model for determination of effective dose, which is to be used when you are well below the limit and for optimization. When you are dealing with some exposure situation where you have a risk of being exposed to a very high dose, we propose to forget the effective dose and to use the real parameter of the exposure of the body and so on. Because you know what I mean, because now you need to know the risk. Effective dose, again, this model are made for calculation of effective dose, and effective dose is again mainly for optimization and compliance with those limits. So this is why you can deal with central value. This is not the same story when you are dealing with several hundred of millisieverts. In that case, you should take the real data.
Okay, thank you.
Well, I think we have to close this session. I'd like to thank again all the speakers and all the people present, and particularly also those who asked questions and gave comments. And the session is closed.